pictures with 28 of these 4-foot containers stacked on top of each other.
4 of these folded containers locked together in one interconnected pack that's the same size as one normal container. Reducing empty containers from 4 down to 1 cuts down on fuel use for trucks and saves space on freight trains. But how much of an issue are empty containers? Is this something that could really offer big savings?
There's roughly 900 million container movements over the world every year, and roughly between 20 and 40% is empty. So we calculated between 200 and 250 million empty movements, which is a waste. Well, if everybody would use foldable containers, then you could reduce this number very, very heavily. So you could save 150 million movements. So that's roughly 15% of all container movements could be reduced.
So let's talk a little bit about the potential drawbacks. So like a bit of extra time to fold them. Are they also heavier?
Yeah, the containers are a bit heavier. We use more steel to make it a stronger container and to be able to carry the same weight as a normal container can carry. And we have the folding equipment in the bottom, which also weighs a bit more. So our container weighs roughly 25 to 30% more than a normal container, which is 4 tons, a normal container, and this one is 5.5 tons. And some people ask us, why didn't you make a lighter material? Well, you see here already in the ports, there's a lot of movement, there's a lot of collisions, etc.
Yeah. So we can see on the back of this container that's just leaving on the back of a lorry is pretty dented up, so
Yeah.
it needs to be durable.
Yeah.
You're listening to Crowd Science from the BBC World Service. I'm Anand Jagatia, and in this episode, we're answering listener Paul's question: can we improve the shipping container? We've seen just how huge the international shipping sector is. Nearly everything we own comes to us in a container, with hundreds of millions of these things moving around the world. And given that each of them weighs a few tons, it is possible to make the container itself more efficient by using different lightweight materials or innovative new designs. But there's another way that this vast network can be improved: logistics.
We have a vision to reinvent and digitize the supply chain and make global trade easy for everyone, because the shipping industry is an old lady.
This is Trina Nilsson, who works for a shipping logistics platform called Flexport.
The logistics industry is very fragmented, especially on the technology side. The number of players and the number of documents that are involved makes it very, very difficult to have one technology that covers all of it. So what we try to do as Flexport is make sure that customers on one platform can see the journey of the goods all the way from the supplier in Asia until you receive it at the final destination in the UK.
So how can logistics help us to, use less fuel or send things more energy efficiently around the world?
It's estimated that about 30% of all containers is air, which means that it's not full. So imagine if you could cut 30% of all the ships or containers, that would already have a massive impact. There's a lot of companies who might have 3 pallets, and then they think, okay, let me just get a container because I need these pallets to move and I need to move them with speed. And what we're trying to do is help customers combine their demand with other customers' demand. So if you have 2 companies who each have 6 pallets, then we combine those pallets and put it into one container. It's both good for the environment, and it's also very good for your cost.
As well as reducing empty space in containers, they also use data from shipping routes and machine learning to better predict container delivery times. Shipping isn't always the most reliable, and late containers means the stuff has to be sent via air to make up lost time, and that has a much, much higher carbon footprint.
There's so much potential in machine learning and AI, and I think we've only seen the beginning of it within the shipping industry. So one of the things that we're investigating heavily at the moment is how do you design the optimal route. We're not there yet, but one of the things that we're starting to prepare for is being able to look at all the vessels that are departing from Asia and then create much more sustainable routes. There's, for example, a number of methanol ships available where you actually have a much greener solution than the traditional ships. So what we want to be able to do in the future is also try and help customers steer their own demand towards the more sustainable solutions.
Are you seeing a sort of push or an increase in demand within the industry for greener shipping? Like, will companies say, actually, we want to prioritize this more than we have in the past and we're willing to pay for it? Are you seeing a shift?
Yeah, we're seeing a shift.
Listener Paul wanted to know if we could improve the efficiency of shipping containers, and the answer is a definite yes. Let's run through some numbers. Using lighter materials like aluminium could decrease fuel and emissions by 17%, while switching to a foldable design could cut the number of container movements by around 15%. And smarter logistics like optimized routes and reducing empty container space could save 20 to 27% on emissions. Now, we can't just add these percentages together because, for example, it might not be possible to make foldable containers out of aluminium. Even so, these numbers are a lot higher than I thought they were going to be, and they are pretty impressive. But I can't help thinking that we still need to do much better given the scale of the climate crisis. Paul asked us about improving containers in order to save fuel. But let's attack this problem another way. Can we lower shipping's carbon footprint by using greener energy sources? Trucks and container ships still run on fossil fuels, and that needs to change if we want to get emissions from shipping containers all the way down to zero. And there are people working on that very challenge.
I'm Tristan Smith. I'm a researcher at University College London, where I lead a research group that is focused on the decarbonisation of the international shipping industry. So overall, across all types of ships, we have a total of about a gigaton of CO2 emissions per year, which is equivalent to a country the size of Germany or Japan. It's one of the largest sectors in terms of total emissions. Now, container shipping is just a subsection within that, but it's the dominant section that's responsible for about a quarter of those emissions, in terms of about 250 million tonnes of CO2 is emitted per year moving containers around.
Tristan spoke to us from a hotel during a work trip to Singapore. He told me that decarbonising shipping would involve transitioning nearly 50,000 ships away from fossil fuels, which is something the International Maritime Organization has committed to do by 2050. Tristan explained that there are 3 high-level options for meeting this goal.
You can put a battery in a ship just like you can in a car. You can run it on a liquid biofuel or a gaseous biofuel, or you can use renewable electricity to make hydrogen and then use that hydrogen either as hydrogen itself or turned into another molecule that's similar or uses that hydrogen.
Batteries are fine for short distances or small ships, but not for the huge vessels that transport 20,000 containers across entire oceans. Biofuels, which are made from crops or food waste, are complicated to produce at the scale needed for the industry. So Tristan says that hydrogen-based fuels are our only realistic option. There are various different kinds of these, but companies need to agree on a single fuel to transition to, so their ships can easily fuel at any port. According to Tristan's research, the current best choice is ammonia, which is a combination of hydrogen and nitrogen. He says it wouldn't be too difficult to switch to, and it's less polluting than the fuel it would replace, although it certainly isn't perfect.
So the nitrogen in the ammonia molecule can combine with the oxygen during the combustion process, and that can produce NOx, which is a harmful air pollutant. You can get N2O, which is nitrous oxide or laughing gas, which is also a greenhouse gas, and you can get some slip of the ammonia itself. So it's not a free, there's no easy free solution. There are other problems that you can get when you're combusting hydrogen. You would also get a NOx emission because it's the temperature of combustion that causes that. So all of these options have various different emissions byproducts.
I mean, my only experience of ammonia is sort of as like a household cleaning product, and it's kind of nasty stuff. Are there any safety concerns around it being toxic or anything like that?
Absolutely. So ammonia is toxic, but it's also highly corrosive, and so it can have a long and lasting impact on both people and animals and ecosystems. We already ship about 15 million tonnes of ammonia around the world. We just don't use it as a fuel on board ships. So we have to make sure that crews are trained and safe. And so we don't call it refilling your car, we call it bunkering of ships. So the bunkering operation, which is when you transfer the fuel from either one ship to another or from land to a ship, that operation can be very risky because you're pumping ammonia at very high flow rates. And if something went wrong during that operation, you would have some pretty nasty consequences.
In the longer term, if we did move away from fossil fuels and move to some of these alternative fuels, how much greenhouse gas emissions could the industry cut back on?
So I don't see a reason why it couldn't reach zero emissions. If you make everything from renewable electricity in the ammonia supply chain, you should be able to get to 90-95% lower greenhouse gas intensity. But the last 5 or 10% gets really difficult because at some point you have to make the materials in the supply chain out of something, and that normally takes energy. But as long as we're decarbonising all sectors in parallel, so the steel that you make the ship out is also being decarbonised at the same time, then we are in a position where we could have a virtually zero emission international trade system that then provides the basis for sustainable development, because it's how people in the West bring their goods that give them the standard of living that we're used to, but it's how many other countries have enabled their economic development.
Since we've started making this episode, I've been seeing containers everywhere I go, at train stations, on trucks and by the side of the road, and every time I've thought about how they have changed the world. But if we want to make our world sustainable, we need to change container shipping. The good news is that improvements are possible, and if we also move to cleaner fuels and electrified trucks, we should be able to achieve completely emission-free shipping. But the industry is huge and has a lot of inertia. Just like a giant container ship, it's going to be difficult for it to change direction easily. Paul, I hope that's case closed. Over to you for the credits.
That's it for this edition of Crowd Science. Today's question was from me, Paul, in the UK. If you have an out-of-the-box science question that you'd like made into a programme by the Crowd Science team, email crowdscience@bbc.co.uk. This episode was produced by Sam Baker and presented by Anand Jagatia. Thanks for listening.
You're listening to the BBC World Service, and here's what's happening in the studio this week.
We're with the Argentinian artist Admin Aliti, known for combining art and nature with their bold, colourful geometric work. They're creating an outdoor installation that's to be enjoyed by humans and also be a welcoming space for birds as well.
In the studio, Tuesday at 12:30 and 21:30 GMT. In 30 minutes, Pick of the World with Anna Dilble.
Re-believing in yourself, how an entrepreneur made Ghana the home of a luxury watch brand, plus love, stars and a telescope. All our top digital and social stories this week.
People Fixing the World is next. This is the BBC World Service, the world's radio station.
On Going Bananas on the BBC World Service, we unpeel the truth behind the future of the world's most popular banana. It's called the Cavendish, and it finds itself under attack from a killer fungus known as Tropical Race 4. It travels through the soil at lightning speed and can wipe out entire plantations. No wonder Colombia declared a state of emergency when it first appeared there. We hear from banana producers waiting for the fungus to strike.
It's difficult to imagine what we'll do if we couldn't grow bananas.
In this programme, I'll be travelling to Austria, where nuclear scientists are hoping to save the banana by creating mutant strains that could be resistant to this deadly disease.
So this is the Gamma Cell 2020, where we'll be subjecting our banana tissue culture for irradiation.
So join me, Harry Wallop, as I investigate what's being done to save the planet's most popular fruit in Going Bananas.